Alright, so in this question, we are told that point O is the center and OT is parallel to QR. OT is about 8 units, so the length of OT is 8. Okay? That's, so this is 8 units. Alright, so we want to calculate the length of PR over PT. For us to be able to do that, we need to find the length, okay? The length of PR and the length of PT. Now, if you look at this diagram, you'll find that this is actually a semicircle. Okay? So you know that an angle subtended by a diameter at the circumference is equal to what?
2 times
90 degrees. Okay? Okay, can I have your attention? Can I have your attention? So that angle R there is equal to 90 degrees. Right? Since it is equal to 90, right? I can use also the fact that OP is a radii, okay, it's a radius, and OQ is also a radius. Alright? Now, this is where I'm gonna start now. Since point O is the center, right? I'm going to start by saying this question here, you have to write down how you are going to do the question. There has to be a layout. Okay? So I'm going to say OP is equal to OQ. This is radii. Okay? We did that last year. The reason why I'm saying it's radii is because we are told in the question that point O is the what? The center. So those two are equal. Now, because those two are equal, it therefore means that I can write this down. Okay? Because I can write this down. I'm going to write it down now. I'm going to say in triangle PRQ. Okay, in triangle PRQ, because OP is equal to OQ and line TO is parallel to PQ. Okay, it therefore also the other thing is that the point from point O to T, this is a line from the center, so it is perpendicular to the chord. Remember, this PR is going to be a what? A chord. But now, remember, we've got the converse of theorem 1 and we've got the original theorem 1. Line from center perpendicular to a chord, or line from center to midpoint of chord. So, which one would we use here? Is it going to be the original theorem 1 or is it going to be the converse? Okay, so here I'll say PT is equal to, can I have your attention? PT is equal to half of PR. My reason for this, line from center to mid, line from center, not midpoint off. Line from center perpendicular to chord.
So I say 0 is equal to midpoint, and then it's given.
Okay.
And then I'll say.
So PT is equal to half of PR. Why? Because OT is a line from the center, therefore it is perpendicular to PR and means that it bisects PR. That's why I wrote that. Okay? Right? I used the original theorem there. Right? So these two are equal. Those two. They are equal. Then once I have got this now, to write the ratio of PR over PT is going to be very, very easy for me. So I'll say PR over PT is going to be equal to. Now check this. I've got here half PR and I've got PT. So all I can do is, if I call PT X, it means that will also be what? X. Alright? and that will make it easier. So my PR is going to be 2x, and my PT is going to be x. So the answer is going to be the 2.
So, you know what? I got the was wrong.
Really?
I thought it was wrong.
Alright. Yeah, I want you to be aware that. Listen, I want you to be aware that the reason why I had to use the original theorem is mainly because of this right angle.
Oh, yeah,
That's the main reason. If you want to use the converse, they have to tell you that the lines are bisected. Okay, it has to be indicated on the diagram that the lines are bisected. If you use the original theorem 1, it must indicate that the lines are perpendicular. Okay, now who can agree with me that if OT is parallel to QR and QR is perpendicular to PR, it therefore means that OT is perpendicular to PR. Do you get that? Right. So I'm done here. Any question? So I've refreshed you on theorem 1 in its converse set. Okay? Let's move on to the next page. Next page, we need to find the length of RQ. Okay? Now to find the length of RQ, it's gonna be easy now. Okay, because we know that OP is equal to OQ, also PT is equal to TR. Which theorem can we use? Which theorem? Don't doubt yourself, it's correct what you just said. It's the midpoint theorem. Okay? So we say for 3.2 in triangle PRQ, alright? In triangle PRQ, I need to find RQ. RQ is equal to 2 times TO. The reason, midpoint theorem. So this becomes 2 times 8 is equal to 16 meters. Okay?
So, please do me.
Alright? Who lost you? If you finish copying this,
No, yeah, I move.
I can't go back until everyone finishes. Yes. It just was that 99 stop that. You do that another, that's the reason why that controlling the content. Stop that. Hey, if you stop talking unless I go, the microphone will pick up the voice. The microphone is going to go for my laptop. Sometimes you don't know how to do the test, but the way you write it down is very good. Okay. Right. So from here, I now need to move on to the next one. So I have now need to find the length of RQ. This one here. All right. For 3.3, we now need to determine the radius of PR. The radius of PR equal to 30 units. Now PR, okay, this is so simple. If you want to find the radius, okay, if PR is equal to 30, right? This is PR. That's equal to what? 30. Okay. So if I wanna determine radius. Remember, your radius is half the length of the diameter. Right. So I know that this is 30. I've calculated R cubed and I got it as what? 16. Right? So I can put what? 16 here. And I also know that TO is equal to what? 8. To 8. So there's more than one way for me to calculate the radius. Now in my case, and I know that if PR is equal to 30, therefore means that PT is equal to what? 15, and TO is also equal to 15. So I can use triangle PTO to calculate the radius. It will be the hypotenuse. Okay, so I'm going to do that. So I'll say in a triangle PTO, right? PT is equal to half of what? Of PR, which is a half times 30, and that will give you 15 units. Okay? Once I have this, then I'll carry on top here. Then I'll say in that triangle, OP squared is equal to PT squared plus OT squared. That's Pythagoras. Then PT is 15 squared plus OT is 8 squared. Okay, so this gives me 225 plus 64. And you get 289. Okay, therefore my OP is going to be the square root of this, which is 17 units. Okay? Are you following?
Yes.
Huh? And then let's do the area one. Now 3.4, it says determine the area of PTO, okay, the ratio of area of PTO to area of PRQ. Okay. Now we have got lengths here, so I can really go to the next page where I've got the diagram. I'm going to put my lengths. Now before I do that, do you agree with me that PTO is similar to PRQ? But you have to prove that, obviously.
Yeah.
We have to what? We have to prove that. Okay? But I'm not going to use similar triangles to determine the area of that ratio. The good thing is in this question I've got so much of information that I can just use the area rule. Okay? I can just use the area rule, but you can also use similar triangles if you want. Okay? So this is 17, that's 17. Right? So our PTO and PRQ, those are the two triangles. They share a common what? Vertex. But their bases are not on the same line. So I have to use the area rule. Let me move on to the next page. So this is 17, that's 17. This is 8, that's 15, that's 15. This is 16. So this ratio, first I'm going to write as, so this is 3.4. Area of triangle PTO is going to be equal to, now it's going to be equal to half times. Now if I consider this as my angle here, means I can say PT times what? PO. So that will be PT times PO times sine P. Also, the area of triangle PRO, okay, that's equal to, sorry, PRQ. It's going to be equal to PR half times PR times PQ times sine P. Okay? So this half goes away, that half goes. The sine P and the sine P goes. Okay? So you are going to be left with PT PT, that's 15, times PO, that's 17, all over PR, that's 30, and PQ, that's 34. Okay, if I simplify this without using a calculator, these two will give me a half, so I'll end up having a 2, I'll get another half here. So the final answer will be a quarter. Okay. And then we are done. Angle R is equal to, just add this angle R is equal to 90 degrees. They're using angle in what? Semicircle. Right? For geometry, it's always wise to provide more information than less information. Okay? It's always wise to provide. So you could have written that somewhere. Yes?
What about angles substituted by diameter?
Yes. You can also get that easily. But the most common one is angle in a semicircle. Okay. I would suggest that you use angle in a semicircle. I think that's how I told you last year. Right. In the examination guideline, that's the most common reason. Any other question? No, it's not the same. It's not the difference. You see here, once I get here, I need to write here and say, therefore, the ratio of area of triangle PTO is to area of triangle PRQ is equal to 1 is to what?
Where did you get the units, sir?
Okay. Alright? The 30 came from, we are told already that PR is 30, so we're told here. In question 3.3, PR is equal to 30. Okay. Remember, your answer must be a ratio, so even if you get it as a fraction like that, just write it finally as a ratio. Like, like this. Okay.